Good morning, and thank you for attending Blue Water's webinar on dairy wastewaters. My name is CJ Strain. I'm the Chief Technology Officer for Blue Water Technologies. I gave everybody a little extra time this morning to join us. We had a few late arrivals, so I went about 20 minutes past the hour here. I'm glad that you've all been able to join me this morning. Give you a little background on myself. I'm a professional chemical engineer, having worked in a variety of industrial roles over the last 15 years. My primary focus is in the wastewater industry, is in process development, as most of you would know, having met me at local conferences or national industrial conferences as well. The format for this presentation will be pretty simple. We're going to start with an introduction to the challenges and then transition to process technology that meets some of the challenges that we highlight, and then we'll wrap with Q&A. So if you look at the interface pane for GoToMeeting, there's a location for asking questions. If you wish to ask a question anytime during the presentation, feel free to type in your question, then we'll address it at the end of the presentation. So let's begin with a brief discussion of the challenges. Whether a site has its own discharge permit or sends its wastewater to the regional municipal plant, BOD and solids are a significant concern. Outdated technology or overloaded systems, either from solids or hydraulically overloaded, they can lead to higher operating costs. As an example, we installed an EcoMat rotating belt filter system on a way-digested stream that was discharged into a lagoon system. And the lagoon system was so overloaded with BOD and solids that the site producer had to truck in liquid oxygen for aeration of that lagoon system to keep it from going septic. Following the implementation of the EcoMat rotating belt filter, they were able to go back to compressed air for their aeration needs, which of course would have a significantly lower operating cost. So less than a 12-month payback in that scenario. So, solids, they can be a big challenge. The sludge collection, disposal, reliability and sustainability of existing processes and processes that are in design is a really key focus for Blue Water. A properly sized system with a well-engineered treatment process flow will be more economical. And I use the word, reliable, but it boils down to the economics, the overhead. An unreliable system is a costly system. And a costly system cannot be sustained over the long term or even over the short term in a lot of cases. As an example, I saw one application that was designed, ultimately they also had some nutrient criteria as well, but there was a compressible media filter installed as part of the plant treatment flow. I'm not really a fan of the compressible media filters to begin with, but in this particular application, it was a very poor choice. The media had many issues with plugging, eventually collapsing, causing problems for all the downstream treatment steps, and ultimately led to compliance issues and very large headaches. The unit process needs to fit the application to be reliable and sustainable. And lastly, I want to stress nutrients. We all know that tighter nutrient limits are coming. In many states, we've seen those nutrients arrive, and they're coming very fast in other locations and other regions as well. So we're seeing tighter phosphorus restrictions, and often we see some nitrate restrictions as well. I have a visual on the screen from the EPA website showing the progression of individual states towards compliance with the Clean Water Act. So on the screen you see the various states like Wisconsin and Florida, both places where criteria has been established. They're making progress towards implementation and compliance with the Clean Water Act. Other states over the coming years are going to be establishing and implementing criteria as well. Now this graphic is available on the EPA website noted on the screen, and it's interactive. You can look forward several years and see the progression of various states towards compliance with nutrients. So again, as I mentioned, Wisconsin, Minnesota, they're pretty big. Illinois is a little slower. It's going to get there eventually, but they're not there yet as far as the nutrients go. But some of the other challenges that I noted might be applicable in those regions. But ultimately, whether we're talking about the solids or the state of the system, nutrients, it's all going to come down to the cost of non-compliance. If we're not in compliance, we're being hit by heavy surcharges. We might have regulatory agencies threatening plant shutdown, that kind of thing. And those are costly events that we certainly can mitigate with effective wastewater treatment. So Blue Water knows wastewater. We know the challenges and economics of treatment and have applied decades of experience in multiple industries that share challenges with dairy producers. We utilize our expertise, a very capable operations group, and state-of-the-art treatment systems to conduct treatability studies, pilot operations for plant design, and implementation of cost-effective solutions. We have a variety of options and services available, as you see on the screen at this time. And really, it pays to look at your existing treatment trains, not just if you're having trouble with upcoming nutrients, but again, overloaded systems that aren't optimized. They have higher chemical costs, etc. So it does pay to look at these systems, and whether it be on a bench scale for chemical optimization, or on the pilot scale, or if you are truly in design to come into compliance for nutrients. The payback on process improvement is there for most producers in the industry, and many that we've worked with have a payback in under 12 months, depending on a variety of variables, including the state of their current treatment system. I mentioned our treatability studies. We have a state-of-the-art laboratory where we can conduct process modeling with basic chemical optimization. This is a good first step in selecting unit processes to take to pilot and design phase. The level of information that we can gain on the bench scale is often appropriate for full-scale system design. That's at one extreme. At the other extreme, we'll use them as a simple litmus test on whether we should proceed with a pilot and truly model the process. But you see a few images here on the screen. We can do media columns for nutrient compliance, TSS polishing, clarification systems, as you see noted here on the screen as well. These central pictures are dairy applications. This first picture here in the background, that is a whey digestate stream, and that's actually the lagoon system that I mentioned before, where an EcoMat rotating belt filter was implemented with a chemical system to reduce the solids and BOD loading going into a lagoon. Here's another stream at a different site altogether, where the same application or the same equipment was implemented, again for solids and BOD mitigation. And you can see very effective process. Again, we bench scaled the chemistry, made sure that we could separate the solids very well. We used a rotating belt, an EcoMat rotating belt filter for the physical separation process. You see a generation of a slurry or a sludge, a very thick, very high dry solid sludge there in that picture there, and there's a picture of the effluent water for that application as well. So if you're looking at solids mitigation, nutrient control, etc., a lot of these processes can be bench scaled at a very economic price and cost to the user before proceeding to a more costly either pilot or system design. Speaking of pilots, often before proceeding with that final design, unit processes can be mobilized to dairy producer sites to gather modeling data, and this is the case, or this was the case in that lagoon application that I mentioned. They had a problem, overloaded lagoon, liquid oxygen on site. We bring in a rotating belt filter. We completely demonstrate the process and model the process, and then at a later date design and implementation of that process. So this is a great way to get some early information model the process. And there are, several reasons for contracting pilot services. It could be treatability projects like we've talked about, pilot scale for design. It might just be looking at the economics of process improvement or gaining confidence in the process. Also, very popular is while you're in that implementation and construction phase, it's possible to have contract treatment. For example, we've been in sites that they were close to a plant shutdown. They needed a solution right away, even if it was a temporary solution. So we could bring mobile equipment on site to treat their plant flow while they were into permanent construction. Our pilot fleet is very capable. You see a turnkey plant here for nutrient control. This is a Blue Pro system on a 50-foot trailer with all the controls. That one actually takes about a day to set up, and it's online. You see an EcoMat rotating belt filter here for clarification, a DAF system, a small pilot DAF system as well for plant modeling. So very capable ops, very mobile ops program, and very economical for plant modeling at a pilot scale. I have summarized some of the challenges to wastewater treatment in the dairy industry. And from here on out, I'm going to be highlighting the unit processes that are integral pieces to an effective solution. So you see a process flow diagram here on the screen, anything from screening, grit removal, clarification. Some sites have biological treatment on site, followed by clarification. There may be filtration prior to discharge or sending the water to the POTW. But ultimately, my message here is Blue Water is a solution provider, focusing not only on the unit processes where a standalone addition is applicable, but we can also provide a turnkey integrated solution to the treatment challenge. Any level of this process flow diagram is within our wheelhouse. We have a very capable manufacturing shop. We have a UL panel shop where we do customized controls. It's very helpful to seamlessly tie into your existing SCADA system. We're a USA manufacturing company, so all of our systems are US made. Anything from mobile systems to turnkey package plants or unit processes. So that's Blue Water in a nutshell. And this basic process flow diagram will serve as an outline for the equipment that I will be discussing, beginning with the EcoMat rotating belt filter. So those who have not seen this equipment before are in for a treat. We have a more in-depth video available on our YouTube channel, which can be accessed through our website. But to give you a broad overview, essentially the EcoMat rotating belt filter is a more compact and economical alternative to sedimentation. It works great as a primary screening and filtration device in the dairy industry. I've mentioned a couple of case histories already. Its performance and capture rate is usually enhanced in dairy waters by adding coagulants, although there are some applications where it works perfectly well as just a physical separation process, at the front end of a process flow. Blue Water's history with rotating belt filters goes back more than 5 years. The technology, the umbrella technology, rotating belt filters, they've been around for about 20 years. Blue Water's been supplying them to the marketplace for the last 5, and about 2 years ago we launched our own product line, and we've expanded that product line since. And really our focus with our US-made product line was to reduce the capital costs and really rethink the system from an operations and maintenance perspective to reduce those costs, to reduce the operations costs. So the core technology, very easy to operate. It's fully automated. It's modular. We have a range of units of models within the product family, but it's also a very modular product. So those different models can be implemented in parallel to treat any range of treatment flows from 20 gallons a minute up to several thousand gallons per minute. Some of the largest plants in the world with this technology are over 100 million gallons per day on the municipal side. So a very modular and flexible footprint. Now, the focus is really decrease chemical costs. So I've mentioned systems that are overloaded with solids or hydraulically. DAF systems are very popular within the industry. And these systems can be implemented in front of those existing systems, DAF systems, to decrease the current operations costs. And quite often there's a payback, a significant payback in doing that. We talked about increased aerobic capacity, that lagoon system example that I used earlier. And really, again, we focused on this product line providing superior clarification and screening performance. It's a proven, reliable, and pre-engineered product, very easy to implement, very cost-effective to implement, and it's U.S. made and serviced. EcoMat rotating belt filters achieve their separation efficiency by enabling a mat of solids to form on a sieve belt. So you have a cartridge-mounted belt, looped mesh, that's continuous. You have an influent flow here. There might be chemical addition up front to coagulate large particles to enhance the capture rate. But ultimately, you're getting screening to the sieve size of the belt, and then you're building up a mat of solids on the belt that acts as basically a filter. So you get filtration capacity. The solids are conveyed up out of the influent stream, so the water flows across the mesh. Clean water flows out the bottom of the unit. The captured solids are conveyed up the screen and discharged to a sludge conveyance bin with an integral conveyance system. And then there's a belt cleaning device mounted just underneath the head roll. So we see a picture of it in this to the right, below right. There's an influent well with a water level controlled, and there's a mat of solids that you can see on this belt. And I have other pictures as well that we'll be sharing. And then those solids are discharged into the conveyance bin. Now, again, our focus was low energy design. It's fully automated. There's fully programmable cleaning cycles that are interfaced via touchscreen PLC. So very operator friendly. Push of the button kind of stuff. There's degreasing options which apply to these industrial waters that we're talking about. And the maintenance, again, this entire system was really designed to ease maintenance and minimize maintenance and operator interface with the equipment itself. The EcoMat is appropriate for several industrial applications. You can see that the mat forms on the mat that forms on the sieve belt looks very different depending on the industrial application. I've got some primary municipal treatment. You can see the mat forming there, algae capture, poultry and meat kill plants, textiles, pasta producers, and then we have our dairy picture here in the lower left. So again, this is a shot down at the influent well where you have all of the solids coming in. This has been pre-treated with chemicals, so everything is nicely coagulated and flocked together, and then it's going to form a filter mat. It looks very much like this here on that belt for separation efficiency. And as I mentioned before, it's applicable to this wide variety of applications. It's very easy to retrofit and to expand existing treatment capacities simply by retrofitting this upstream in the process. I mentioned a variety of different applications. They're all on the screen. It's a very simple technology to customize. We can adjust the operating parameters. A couple of the design features have options that can really customize to a variety of different industries. Obviously, we're talking about dairy wastewaters today, but it's been used in all of these industries. Membrane pretreatment is a great one because it removes all of the fine particulate, the grit, the hair, that kind of thing. But again, it's a great tool for the dairy industry because it gives you more bang for your buck out of the chemical costs and the operations costs that one would currently have. Here's an installation that has a good story of success. This plant was facing the shutdown if it couldn't clean up its water. It had an existing overloaded DAF system and struggled to maintain 500 milligrams per liter TSS in its effluent. And it had a very high operating cost. So ultimately, what the solution to the challenge came down to was it was a very simple process addition. So they had chemical treatment followed by a DAF system that was just overloaded. The EcoMat was placed between the chemical system in the process flow and the DAF system. So it would take all the bulk, the majority of the solids out, maybe 80 to 90% capture even of those solids. And what that did was it took the overload off the DAF system, and that was then able to operate as designed. And so now they're making water that often averages, anywhere from 50 to 80 milligrams per liter effluent TSS, and they're meeting their BOD requirements as well. So it's one of those good case histories of a simple retrofit. This one's in Illinois, and it started with the bench program that we highlighted earlier. Then went to a pilot phase, which is where most of the images you see on the screen were taken from. And now the system is installed and operating for the client. They were able to keep the plant from having to shut down, to go offline from the regulatory compliance issues. And again, I want to highlight that information on EcoMat rotating belt filters is available on our YouTube channel. We have a standalone video that really explains that process in depth and in a lot greater detail than I'm able to go into here. Since I'm limited on time, I want to talk about some of the other processes that we have available. And a lot of the dairy processes, they're very simple. It can be just a clarifier. With the upcoming nutrients, we're going to be talking more filters as well. So again, it could be a variety of different solutions that are effective pieces to meet the upcoming and current challenges. One of Blue Water's clarification options is our EcoDAF process. We utilize a very progressive whitewater design to minimize chemical addition, energy costs, and recirculation volumes. In addition to being able to retrofit existing DAF systems and to make them operate more efficiently with less chemical, we supply turnkey DAF systems that come in, and they provide a very high degree of TDS and TSS reduction. They're very compact footprint. And again, our focus is on being the lowest chemical consumer and the lowest energy consumer for the level of treatment that we can achieve. Another clarification process that we have available that we've implemented across the industry is the Eco 55 IPS. It's an incline plate settler. Basically, it gives you the settling capacity of conventional sedimentation clarifiers, but in a much more compact footprint because of the incline plates. We have the same projected area for settling, but again, in a much more compact footprint. Our designs are, state of the art. They work very well for separation of solids that will settle at a reasonable settling velocity. So this can be a very low cost addition to a existing treatment process, or one that needs a treatment process. I mentioned sludge management, and I'm going to just briefly touch on it before we talk really about the nutrient control, which I think is one of the biggest upcoming challenges for the dairy industry, especially in states like Wisconsin, Idaho, and various other parts of the Midwest and East. The Blue Press is a line of screw presses that Blue Water provides for dewatering. They've been used in a variety of different industries, and they're great for reducing the water content of the sludge, reduce shipping and hauling costs, and to really mitigate the sludge management issues and logistics that a site would have to plan for. So we have that option in our arsenal as well for that piece of the process flow. Now I'm going to switch over and really focus on our nutrient mitigation technologies. Now these technologies we implement within our CentraFlow filters. They're continuous backwash upflow sand filters, and they're used for reuse water as well as for simple TSS polishing and nutrient mitigation in industry. But there's several really strong features that make this very applicable to dairy dischargers. They're gravity sand filters, so there's no moving parts. They're very economical to run and maintain. And Blue Water fully models these systems in 3D CAD before building and providing them. So you can do plant layouts very easily with this modular system. These filters, they're continuously backwashing. So it's a very low flow continuous backwash, and that's key because a lot of other filtration systems are high rate periodic backwash systems, and so they'll completely shut down a cell and backwash that. And when that cell comes back online, there's a lot of carryover issues. That can be a huge challenge when dealing with the lower phosphorus limits that we're seeing in Wisconsin, like a 0.07 or 0.05. You just can't have the periodic high rate backwash and maintain a high treatment level. So the continuous backwash, very even, very consistent, reliable effluent quality is key to the success of a good nutrient control system. I mentioned no moving parts in water reuse quality. It's accepted throughout the U.S. for water reuse, so that's really the basis of this platform. The way these systems work, and you see a 3D cutout of the system here, water comes in through an influent distribution pipe and enters the filter through a central distribution assembly. Now there's radial arms that are below the surface of the top surface of the media for distribution of the water. So the water flows upward through the media bed, and then it flows over a fixed effluent weir that's at the top of the filter. So in this headspace around this pipework, this distribution pipework, this is all clean water, and that would flow over a fixed effluent weir. Now this plumbing in the middle, this is a wash box. So this is where the media is continuously recycled via an airlift pipe. So there's a central pipe that goes all the way to the bottom of the filter and lifts the spent media to this wash box. And the media is cleaned there, the solids are discharged. When we're doing phosphorus control, we have coatings on our media that are adsorptive. The coatings are stripped and the media is freshly recoated as it falls back down through the active zone of the filter vessel. So that's basically how the process works. A portion of the clean effluent is continuously flowing up through the wash box and is used for reject and exits the filter here at 2. So that's a continuous backwash CentraFlow sand filter. And within that process, we integrate, or that equipment, we integrate our Blue Pro process. Now this is a very high efficiency process for phosphorus removal, for elimination of metals that might be on site discharge permits. So conventional removal technologies that have focused on filtration or coagulation filtration are limited by diffusion. And what that means is if they have a filter vessel, they typically would have 1 or 2 tank vessels in front of the treatment system. The first tank would be a mixed tank, and the second one would be a maturation tank or a flocculation tank, where large particles are allowed to form that physically won't fit through the interstitial spaces of the media. So all of your separation uptake happens within your flocculation tank, and that's limited by diffusion. So your chemical contact is limited by diffusion, and then you're adding sustainability issues to your filtration process because you're forcing particulate and wedging into the media. So you're always operating as a semi-plugged and very unsustainable process. We completely throw that idea of process out the window. This is an adsorptive process, and what that means is we rely on the surface area of the media itself for our contact. So we have a very high surface area filter bed. You can compare it to carbon adsorbers or catalytic converters, where they rely on that surface area for contact. So we're guaranteed contact between phosphorus and our adsorbent, which is a ferric hydroxide or hydrous ferric oxide based coating, which is really the basis of the Blue Pro process. This coating completely covers all of the media surfaces and is very adsorptive to phosphorus and other metals. That's the basis of the Blue Pro technology and Blue Water's success with phosphorus removal in the marketplace. Blue Pro removes 90+ % of phosphorus per treatment stage. So you see a few models here. Again, we model all of our systems in 3D CAD before implementation, do an appropriate plant layout and design. These are our various installations. Now you see here, this is a single stage design. These two noted in Minnesota and California, single stage design, large plant flows for the Blue Pro process, the centroflow filtration system. When we need higher levels of removal, we go to two-stage systems. For example, we have several plants that operate below 0.07 milligrams per liter for their discharge permit. We have a couple in Idaho that are below 0.05. We have a couple in design in Alabama that are having to go below 0.02. So when we need that level of treatment, a lot of times we'll look at a two-stage system, as you see here in the middle. This is an operating system that's installed in Idaho. It's been operating for over a year now. And then this is a cheese plant system also in that two-stage configuration. This is in Wisconsin. A smaller flow, a couple hundred gallons per minute, where you see above ground tanks. And again, you're probably going to pump to that first stage and gravity flow into the second stage prior to discharge. But those are effective configurations for meeting very, very low, some would say even ultra low phosphorus discharge requirements. Now I want to point out a few of the value added process properties that Blue Water brings to the table with the Blue Pro process. We use a ferric chemical versus an alum-based chemical scenario because for one thing, the ferric chemistry is more efficient. It may cost a little bit more per gallon, but because of the efficiency, you're going to spend a lot less money to operate with a ferric-based chemistry. We can achieve lower phosphorus residuals, again, with less chemical, which will ultimately lead to better solids dewatering, and better solid separation as well. I have a comparison here on a 1 mgd basis shooting for a limit of 0.1 milligrams per liter phosphorus. Ferric-based adsorption versus a more conventional coagulation filtration approach with alum. Typical molar dosing ratios apply when you're doing coagulation filtration because, again, you're limited by diffusion. So you're using a high molar dosing ratio to get to a low level of phosphorus. You're generating a lot of chemical sludge. Not only are you using a lot of chemical per year, but you're generating a lot of sludge that needs to be handled and mitigated. And in addition to that, you're consuming a lot of alkalinity. Not a huge issue in the dairy industry, as there's usually alkalinity to spare. But it depends, again, on the application. You know, cow water might be different. Now let's contrast this to Blue Pro, where we're using a ferric-based chemistry. It's adsorption. We use a very low dose. The dose is specifically administered to coat the media within the vessel. So it's independent of the influent phosphorus. We're coating our media within the vessel. Dry chemical usage will be lower, which means your sludge generator will be lower too. And again, all of these features say cost reduction. Again, these are the benefits, the cost reduction benefits that are available to users of the Blue Pro process. I have a few case histories to share with you over the next few slides. Some of these are municipal, but again, our focus here is on nutrients. This first case history is it's in Grangeville, Idaho. It's a fairly rural installation. The engineer was JUB Engineers, and they had a very stringent phosphorus permit that they had to meet, a .067, only for a few months a year. They have a seasonal permit, which a lot of folks are seeing. Most of the time when we implement a solution for a discharger, they're not having to comply all 12 months out of the year. A lot of them are anywhere from 3 to 9 months out of the year, although there are some folks that have to comply year-round. But the system size is roughly 1 MGD peak flow design. The deliverable here, their site discharge permit, was .067 milligrams per liter total phosphorus. Now, we first started this project back in 2008. And in 2008, we went down to the site with a 2-stage pilot system. And we demonstrated this system, demonstrated the performance at pilot scale, and fully modeled the plant. Being a municipal plant, the cycle for implementation was a little bit longer than we see on the industrial side, in the dairy industry especially. But the installation was complete early this year. We had a performance test actually back in February of this year, as you can see from this chart here. So this was the performance test for plant sign-off. You see operating well below that .067 discharge permit line, averaging actually about a .02. So again, a very effective process for phosphorus removal. And really the key behind that is the Blue Pro adsorption. This next case history that I have to share with you is a combination Blue Pro and Blue Knight system that we have installed in Pennsylvania. Now, when we're talking about nutrients, most sites, initially they only have to talk about one of the nutrients, either nitrate or total phosphorus, or the main priorities there. We've seen a lot of systems go in for total phosphorus, and then a few years later, the regulators start talking about nitrogen, and vice versa. We installed this plant initially back in 2009 just for nitrogen, and now the regulators are saying they have to comply with phosphorus as well. The nice thing about this treatment platform, the CentraFlow filter platform, is we can do both processes, the Blue Pro for phosphorus and the Blue Knight for nitrogen. We can do both processes within the same treatment stage. So that's a huge win for industrial producers, for dairy producers that are looking to get the biggest return on their investment. So they can install the CentraFlow filtration system with the Blue Pro process today for current phosphorus needs, and they have an installed solution already available, ready to implement in the future if the regulators start talking nitrogen. So again, this is a dual purpose system. Nittany Engineering was the engineer for this project back in Bellefonte, Pennsylvania, and a very forward-thinking engineer, thinking about future considerations for the site permit. This next case history is Indian Head, Maryland. This is a Brown and Caldwell engineering project. This is another combination Blue Pro and Blue Knight system. A 6 model CF50 design, peak flow at 2.6 MGD. The deliverable here was less than 0.1 on the total nitrate, so very tight nitrate limit in their discharge, and a 0.3 on their total phosphorus. Now, as I've mentioned, what we're seeing in Wisconsin is driving below 0.1. Pretty much across the board. And if you're living near an impacted water body or one that's been deemed critical by, critically impacted by the regulatory agencies, by the EPA, various studies have been done. A lot of those limitations are being driven down significantly lower. We're seeing 0.07s, 0.05s in a lot of places. We actually have installed in Wisconsin some phosphorus removal systems at dairy plants that are meeting a 0.07 milligram per liter total phosphorus site discharge permit. So again, these are very effective tools for meeting those phosphorus needs. Now, I will now open up for questions. We've covered a wide range of topics today. We've covered a pretty broad process flow for dairy wastewater treatment. We've covered the challenges with various site wastewaters, discharging treatment, the costs associated with that. And I hope that I've been able to share some appropriate solutions for meeting some of those challenges. And again, we can start with bench feasibility testing, pilot design operations, and we do have contract treatment options available as well through construction, through design, through implementation of a long-term permanent solution. So I hope all of those these broad overviews, broad topics, have given you some food for thought so that we can enter into the next phase of more of a detailed design for your individual need. So now, again, I want to open this up for questions. If you have questions, please enter them into the lower, into the GoToMeeting pane. There should be a question tab there where you can enter your questions, and we can address those over the next, we have about 10 minutes or so before our time is up here. So one of the questions is, where's the Idaho installation for the two-stage Blue Pro? And that case history was shown. It's in Grangeville, Idaho, and the operators there are very friendly. So, the question was, can we go to a site visit? And yes, the answer is they're very open to a site visit. That's a public, a municipal wastewater treatment plant, so it's pretty easy to set up a tour there. Sometimes it's more difficult if it's a private installation, a private industrial producer. But we do have various Blue Pro installations around the country. We have a very accessible plant in the New England area just outside of Boston that's meeting a 0.07 milligram per liter phosphorus limit. We have installations within the Midwest that are meeting 0.1s on their phosphorus. We also have an installation in Minnesota that's got a low phosphorus limit, but they also have a low mercury limit. So I have alluded to the fact that the Blue Pro is very applicable to metals removal as well as nutrients. So those sites, if it's desired to do a site visit, by all means, we can set that up. I would, just contact the email address that's on the screen and give me some more detail on your individual project. So there's a little bit more question on the Blue Night process, and for that, I'm just going to describe it briefly, and I believe I do have a graphic here that I can go back to that would be probably more helpful as I talk through. But the Blue Night process is a biological treatment process. So on the screen you see a cross-section of a centroflow filter. Within the lower portion of this filter, basically from the distribution piping downward, from the central assembly downward, that's going to be filled with media. And you can think of it as almost an MBBR. It is a fixed film or attached growth system. It's an anoxic zone within the filter. So you have a very high surface area for that attached growth. Very high rates of denitrification can occur. So that happens within the filter vessel. As the media turns over, the wasting rate of the biomass is controlled by that turnover rate. So the biomass will be wasted out of the reject, out of the wash box and through the reject stream. And the adolescent biomass attached to the media would reseed the bed, so to speak. It would return to the top of the bed. So that's the Blue Night process. It forms a very porous film, biomass film, on all components within the vessel, and again can be implemented with the Blue Pro process. One of the questions is, if the DAF is not overloaded, an existing clarification system is not overloaded, is there an advantage to installing and adding an ecomat? And I would say yes. And the reason being is I've had a couple of applications where we've been able to significantly reduce the operations costs, mostly through chemical, by implementing an ecomat. So you'll get a much higher efficiency of capture of the really coarse solids. You know, we're talking a couple thousand milligrams per liter, and knocking that down to under 1,000 going into a DAF system. So the DAF system would require less chemical. The overall process would require a lot less chemical, and you could potentially reduce some of your whitewater recirculation as well. So one of the questions came in about Midwestern installations, specifically Wisconsin. We do have some Blue Pro installations in Wisconsin for phosphorus removal on dairy plants. So you're going to have to contact me directly, I think, to talk about specific applications. Whether they're open to site visits or not is kind of up. You know, it'd be up to the owner. But we can talk about public installations and in facilitating a site visit to some location in the U.S. One request is for data that shows denitrification. It's actually denitrification performance of the Blue Knight. And yes, we do have a very wide library, a very extensive library of operating data. We have probably at least a dozen systems that are combo systems, Blue Knight and Blue Pro operating throughout the U.S. We have many other straight up denitrification systems, the Blue Knight systems, installed and operating as well. So if you are interested in you know, interacting with me on a specific project, I can put you in touch with a regional manager for Blue Water, and we can tailor our design to your specific application. I'm going to need process parameters like flow rate, nitrogen content, that kind of thing. But I will share with you as well the flexibility of the Blue Knight denitrification process. We've installed it on flows where there's just a few milligrams per liter of nitrate dissolved in the water. We've also installed it on flows where there's over 200 milligrams per liter nitrates in the water. So again, it's a very flexible flow or platform for nutrient control, specifically biological denitrification. One of the questions is on regards to another industry, and it's pulp and paper mills. And yes, we have installation references on pulp and paper mills. Please, again, contact me directly regarding that topic so that we can get you some information and talk specifically about your application. And it looks like, oh, we have one more question here. What was the usage of, or what was the flow rate at the lagoon system that I had mentioned earlier where they had been using liquid oxygen before? It was, I believe their peak flow was around 300 gallons per minute, so it was a smaller system. But TSS parameters, I believe, were in the 2,000 to 3,000 range. And so they were removing, you know, their goal there was to get at least 80% TSS removal with the accompanying BOD removal going into that lagoon system. And then, again, they were able to cut their operations cost by going back to compressed air versus liquid oxygen. That particular model for that system would have been our EcoMat EM10 model. And again, if you want, if anybody on this presentation or on this webinar wants further specific process information, we have two videos on our YouTube channel. One specifically on the EcoMat product line that gives an overview of the different models, the process itself. We have another video on the CentraFlow platform with the Blue Pro process and the Blue Knight process, It animates the flow and gives you a much more detailed insight into how the process operates and the flexibility of that platform. So I encourage you to visit the YouTube channel. This webinar will also be posted to that YouTube channel later today as well. Well, it looks like we're towards the end of our questions, and we're about out of time today. So I want to thank you all for joining me on this webinar. I hope that I've given all of you a broad overview of the challenges that producers face today within our economy, within the dairy industry. I wish to thank you for the opportunity to summarize some of the challenges, some of our equipment solutions, and I look forward to discussing your particular challenges and site details in more detail in the future. So have a good day.